Here we're going to show some information on how to solve this problem of fad entanglement. We're going to talk about non-entangling fads, and next we'll move on to other measures to reduce sharp bycatch. ISSF has produced a best practice guide which you can download from the ISSF website, which shows which are the principles by which fads should be constructed and designed. And the principal issue with non-entangling fads is that we promote the use of zero netting in the construction of fads. If you don't have netting in the fads, there's no entanglement. So one of the things is avoiding the use of netting. Other thing is to have smaller rafts of the fad, which prevent turtles climbing onto the fad to rest. And the third issue would be try to construct your fads with materials which are biodegradable. This is the guides that ISSF is proposing, and we're seeing some fleets that are moving towards that direction. There are also regulations that are coming from the Tuna commissions, like the ones in this slide, and we see that in the future it's quite probable that most commissions will ask for all fads to be non-entangling. So here we're going to show you some examples of designs that other fishers have been using in the last few years, and also give you recommendations as to how those fads can be used. One thing with, for example, the anchored fads is that these payaos or anchored fads are built without any netting. They're still attracting tuna and they're still efficient, but these anchored fads are completely non-entangling because they use other materials than net to construct their structures. Up to now there's been a move which has gone from entangling fads towards non-entangling fads, and there's been a transition period where fleets have been using alternative designs in which small netting or tied up netting has been used to construct these fads. When ISSF proposed their guidelines for non-entangling fads, it contemplated this period of time for transition to let the skippers adapt from fads which have been always constructed with netting to move to something which doesn't have it, and these have been kind of an intermediate step which are less entangling, but now we're trying to move to fads with no net at all. And here are some examples of some fads that have been used by different fleets, and they have been used successfully in commercial fishing in the last 2 years or so. This slide here shows one of the most used transition fads up to date, which uses small netting on the top of the raft and sausage or chorizo tied netting under the raft structure. This has been highly successful in the Indian and Atlantic Ocean, but the trouble with these transition fads is that if the tied netting becomes undone, or the netting starts to break down, then the gaps in the mesh become bigger and they're more likely to entangle. So that's why we recommend using no netting. In this next slide, you see a similar version of a fad to the previous one, but this one is completely non-entangling because it's using rope underneath instead of netting, and a cloth or canvas on the top of the raft. In this way, we achieve a non-entangling fad, and the structure and design of the fad is not substantially different in terms of drift and behavior in the water. This is a characteristic fad that's been used generally in many oceans, and we'll see that it has a lot of netting hanging underneath, usually recycled per Seine netting, and also netting on the top. And what this causes, or is more prone to, is to cause entanglement of sharks and turtles, as we've talked before. This other example is a non-entangling version of the previous one. So we still have a canvas underneath that acts as a sail to move the fad with the currents, and we have taken away the netting on the top and the bottom. The structure is simpler and also probably easier to make and even cheaper. Here's an example of a biodegradable fad prototype that has been tested in the Indian Ocean, and it was constructed with materials that were strong enough to last in the water for the expected lifetime of a fad, but after that lifetime they would start to degrade. So scientists at the moment are experimenting and trying to identify which are these best biodegradable materials in terms of price, strength, durability, and we're trying to do studies to identify those materials so that the next step after doing non-entangling fads is doing biodegradable non-entangling fads.
Okay, through research cruises we've conducted, ISSF has sponsored. These research cruises basically put scientists out to sea with fishermen, which is very important so that they're able to interact on a daily basis on a fully commercially rigged vessel in real situations to try and minimize impacts to non-target species. What we've learned from looking at the shark situation, this is oceanic sharks, silky and oceanic white-tip sharks, is that it's certainly better to avoid them completely or to release them from the net to maximize survival, because once they've been loaded on board the boat, they may have already suffered trauma that could be fatal. One concept of releasing sharks from the net, and this is before they're impacted at all, the net is still very large, is to just let the fad drift toward the back of the net. The idea being that perhaps through just a natural drifting of the boat away from the net, the sharks might be congregated toward the back end of the net. We observed this in a research cruise, ISSF-funded research cruise, where indeed sharks, and this is mostly silky sharks, and bycatch were collected toward this bend in the net that formed late in the net hauling process. We kept seeing sharks in this area of the net. If we put a panel in there that we could open and close at will, perhaps this would be a way to release the sharks. And the bottom is just a net diagram showing you in the big arrow where eventually that net panel went in. Here you can see the vessel upon which these experiments were made. We first observed that if we were inside the net at the surface, the natural movement of the boat to starboard during the net hauling process would congregate ourselves at the end of this corner of the net. And in the right panel, you can see sets where indeed silky sharks were congregated there, far away from where the tuna were concentrated. The process of opening the net is quite simple. The observations are made from a workboat at the apex of the bend in the net. If there are sharks aggregated there, then we'd signal the boat to stop rolling the net. We'd hook up the workboat to one end of a line, detach the other end of the line, and this line ran through rings connected to the panel. So just by pulling that, it would cause an opening of about 25 by 35 feet to form in the net. The sharks were often quite right there, very close to the area, but unfortunately they tended to want to remain in the net. So additional experiments are planned to try and either repel them out to that area, out of the net, or attract them out through chumming or some other means. Here is an example of what's happening. Anything in the surface of the net, just through the action of the boat being pulled to starboard and the bow thruster moving to starboard, tends to aggregate whatever's in the surface at this apex of the net, which is a dynamic bend as this net is being retrieved by the power block. And between the two red dots you see on the screen, that's where we place the escape panel. The thing is that in subsequent cruises on other vessels and in other oceans, we didn't always see the formation of this bend, this phenomenon, and this aggregation of sharks and bycatch separate from the tuna. For example, here's another vessel in the same stage of net retrieval, but the net's far larger. So basically, this is part of the process of ISSF cruises to examine ways to mitigate bycatch, but not just by applying something we see in one area to another, but by looking at all different areas and different fleets to see what might be most effective. But experiments will continue with this concept because we certainly know that if we can avoid or release them from the net, that's their best chance of survival. Another experiment that we hope to carry out on future cruises is to take the back down procedure, which was used very successfully to release porpoise in the Eastern Pacific in sets where large tuna are aggregated to porpoise schools, where the net is retrieved to a certain stage, locked down, and then this purse seine boat is backed up, and then causing a channel to form and one end of the net to submerge. And you're literally pulling the net sort of out from underneath the porpoise school. We're wondering if this concept can be applied to fad fishing. So here you see in the upper left panel a set being made, and in the middle a fad connected to a power towboat. The idea is the towboat would keep the fad in the middle of the net, and then during the back down procedure, which is the right top panel, number 3, the towboat would slowly guide the fad out of the back down channel and out of the net. At that end of the channel, there would be observers and video cameras to document what went out and what did not. This obviously is just an experimental proposal that we hope to develop.